Welcome to this explainer. Today, we are stepping into the incredibly fascinating, extremely high-stakes forensic world of deepfake detection. Now, with generative AI pumping out these hyper-realistic images, videos, and audio clips, you're probably thinking it's basically impossible to tell what's real anymore, right? Well, there's actually this whole hidden science, a literal cat-and-mouse game happening right now between digital forensics experts and AI generators. We're going to look at the exact methods these scientists use to hunt down fakes, and I promise you, the clues they look for are going to completely change how you look at the media on your screen.
Okay, let's dive into this. Today, we're unpacking a full forensic toolkit. We'll start with the AI's blind spot, check out some physics and geometry fails, explore digital packaging and acoustics, dig into watermarks and reverse engineering, and finally, we'll wrap up with a doom-scrolling reality check.
All right, Section 1, the AI's blind spot.
So to defeat any adversary, you first have to understand how they operate. And generative AI, it actually has one massive fundamental flaw. Yes, it's a master forger. It learns how to create fake media by analyzing the pixel patterns in billions, literally billions of existing images and videos. But here's the critical difference. It doesn't actually know what a camera lens is. It fundamentally doesn't understand the physical, three-dimensional world that you and I live in. No concept of gravity, or light, or actual geometry. It lives entirely in a flat 2D world. So when it generates a photo, it's not recreating a physical space, it's just predicting pixel patterns based on what it's seen before. It is quite literally faking it, and that lack of 3D understanding leaves some major clues behind.
Which brings us to Section 2, Physics and Geometry Fails.
Because the AI doesn't inherently get our physical 3D world, experts literally treat an image like a physical crime scene. Let's start with the outdoors. Think about it. When you take a picture outside on a sunny day, there is only one dominant light source, right? The sun. Because of that, every single shadow in that image absolutely has to obey strict 3D physics. Forensic scientists use these cool geometric techniques to pick a point on a shadow, trace it back to the object casting it, and calculate exactly where the light source must be. And they don't just do this once. They do it for every single shadow they can spot. If those shadow lines do not mathematically converge perfectly on one single light source, boom, the image is physically implausible. The physics just completely break down.
Beyond shadows, we have projective geometry. Imagine standing right in the middle of parallel railroad tracks. Actually, quick aside, please don't really do that. But if you're taking a photo standing between the tracks, you know in the physical world, those tracks are going to remain parallel forever. But the moment you snap a photograph, turning a 3D space into a 2D image, those parallel lines will appear to converge at what we call a vanishing point. This happens because the size of an object on a camera sensor is inversely proportional to how far away it is. It's just strict math, and it applies to parallel lines on buildings, windows, sidewalks, you name it. Experts map these lines out, and if they don't perfectly converge at the vanishing point, the geometry is violated. It's a fake.
Now, what's really interesting about this slide is that the AI acts a whole lot like a classic Renaissance painter. Artists have understood vanishing points for hundreds of years, right? They routinely fake 3D depth on a flat 2D canvas, and honestly, things in paintings are often completely physically implausible. But our visual system, it simply doesn't care. We look at it and we just see a beautiful picture. The AI fakes it brilliantly for our easily tricked human eyes, but the second you apply the strict, cold math of geometry, the lie is instantly exposed.
Moving right along to Section 3, Digital Packaging and Acoustics. We've looked at the physical clues inside the picture itself, but what about the invisible, digital fingerprints of the actual file? And this brilliantly illustrates how we can track the origins of a file without even glancing at the image. When you ask an AI to make an image, it generates the pixels, that's the product, but then it has to bundle those pixels into a file format, like a JPEG. Think of it exactly like buying something online. You get your product, but it arrives inside a cardboard box. Apple packages its pixels in a very specific, optimized way when you snap a photo on an iPhone. Photoshop packages pixels its own way. And generative tools like Midjourney or OpenAI, they have incredibly distinct digital packaging. Experts can totally ignore the picture, look directly at the underlying code of the file's packaging, and identify exactly where it came from.
And hey, this exact forensic logic applies perfectly to audio deepfakes too.
If you record real audio in a professional studio with soft walls, the acoustic reverberation is super minimal and highly consistent, all based on that room's specific physical geometry. But when AI generates audio, it isn't physically recording in a room, is it? It really struggles to maintain that consistency. So forensic analysts listen for unnatural modulations. They're listening for inconsistencies in how the simulated microphone is supposedly picking up the sound, or these weird little shifts in the reverberation that simply would never ever happen in a physical space.
All right, Section 4, Watermarks and Reverse Engineering. Up to now, we've basically been talking about passive analysis, examining a file after the fact. But tech giants are actually implementing active, undercover tactics right at the moment of creation. Imagine holding a modern $20 bill up to the light so you can see those hidden watermarks that prevent counterfeiting. Companies like Google are doing the exact same thing digitally. They're embedding completely imperceptible watermarks into AI-generated images, audio, and video. You can't see them, you can't hear them, and the bad actors can't see them either. But forensics labs have specialized software. When they scan the file, a hidden signal lights up, basically shouting, "Hey, we made this."
The other really cool active strategy is reverse engineering. Experts will literally go out, download open-source deepfake software, like those face-swapping programs, and tear the code completely apart to see how it ticks mechanically. For instance, they discovered that when a face swap tool runs, it actually puts a square bounding box around the target face, pulls that original face off, synthesizes the new fake face, and then pastes it right back in. To our naked eye, the swap looks totally flawless, but because the experts know exactly how the code pasted the face back in, they know exactly how to search the video for the invisible mechanical artifact left behind by that original bounding box.
But here's the catch. That bounding box trick is just one example. Forensic experts are incredibly quick to point out that they keep the vast majority of their methods a tightly guarded secret. It is an absolute arms race out there. Think about it. If the scientists publicly announce exactly how they're catching the fakes, the developers creating the AI tools are just going to update their code and patch those flaws the very next day.
And finally, Section 5, the doom-scrolling reality check.
So, we've talked about all this brilliant, high-level science, but let's bring it right back to you and me. This is really the ultimate question, isn't it? After learning all about vanishing points and light source convergence and digital packaging, how do we actually spot these fakes when they pop up in our feeds?
Well, the harsh reality is we really can't. So the crucial point is this: you absolutely cannot rely on your own eyes or ears while you're scrolling. The technology is just evolving way too fast. Even if I told you a foolproof tell to look for today, like, say, a weird shadow or messed up fingers, that tell is going to be outdated and fixed by the AI in about 6 weeks. If you rely entirely on your ability to spot the fakes yourself, it creates a massive false sense of security. Honestly, even the top digital forensic scientists, the people who literally do this for a living using all the crazy advanced software we just talked about, even they struggle to do it reliably just by looking.
It's a pretty sobering realization, isn't it? We are right in the middle of a digital arms race where the line between the physical world and the synthesized world is blurring faster than ever before. If the absolute best minds in projected geometry and digital forensics are struggling to keep pace, how vulnerable is our own perception of reality the next time we open an app and start to scroll? It's a question we absolutely need to be asking ourselves every single time we consume digital media. Thank you so much for joining me for this explainer. Stay curious and always, always question what you see.